Today we will talk about the self-locking control circuit. In this circuit, L represents the live wire, and N represents the neutral wire. The stop button is denoted as SB, and is connected to a normally closed contact, while the start button is denoted as SBE and is connected to a normally open contact. Presents the normally open auxiliary contact of the contactor. In this demonstration, we are using the main contact of the contactor, which is connected in series. The coil of the contactor, denoted as Km, is responsible for controlling the contactor. When the start button is pressed, the contactor is energized and held in that state. On the other hand, when the stop button is pressed, the contactor is released. The working principle of this circuit is as follows. Initially, the control current flows through the normally closed contact of the stop button, then reaches the start button. When the start button is pressed, the coil of the contactor is energized, causing it to activate. Once the contactor is activated, the power supply continues to provide power to the coil through its normally open contact. At the back end of the stop button, there is a control line connected in parallel with the start button. After the contactor is activated, the normally open contact becomes a normally closed contact, which ensures that the coil continues to receive power, thereby keeping the contactor in the activated state. This is how the self-locking mechanism works.